So we'll call the meeting to order. I am still expecting Mark, but I want to respect everybody's time this evening.
Do you want me to send her a message?
It's okay. I mean, at this point, who knows with the farm what might have come up. So we'll call the meeting to order. This is a special meeting of the Montgomery Select From the board in the room right now, we've got Suzanne Delois, Charlie Hancock, Emily Kimball, and Leanne Barnard. We've also got Walter Knight in the audience, who was a former member of the Wastewater Committee. And we've got Brent Godin, who is our constable, but also just local hero extraordinaire. And we also are being joined on Zoom by some members of the community. The meeting is going to be recorded, both the Zoom and we've got a Northwest Access TV recording as well for posting later for those that can't be here tonight. So the topic of tonight's meeting is the proposed wastewater system for the center and the village. Basically, what we've gone through up till now is to complete the preliminary engineering work. Hey, Charlie. To complete the preliminary engineering work to get us through essentially the preliminary systems designs. The reason we're meeting tonight is because the board is essentially at one of the kind of hold points that we had talked about before. This is where we're going to transition into the final engineering work. It's another point for the board to kind of stop and, deliberately give a green light, just because of the funding aspects. Up until now, the work has been funded through basically what we're going to call no-risk capital, planning dollars that are not repaid should the project not move forward, and or subsidies through CWSRF. So at this point, to advance through final engineering with the engineering service agreement that's been presented to us, which the board has seen, we would now be moving into a position where we would be taking out a loan through CWSRF. So this is where we're basically committing to getting a note that needs to be paid back. So there's a kind of a pivot in the funding here that the board needs to be aware of and consider as well. So John Riley and Dave Edson from Hoyle Tanner are joining us tonight to talk about essentially what have we done so far, what have we learned from that, where are we now, and then where do we go next? And so the where do we go next part is going to be the ESA, the Engineering Service Agreement for Final Engineering, and moving ahead with that. And then there's also some discussions tonight around the disposal fields for the system and what we've learned through the work we've done, and then what the essential options are on the table moving forward. And the board needs to be aware of that and some decision points there. And so the hope is that coming out of this meeting, either tonight or in short order, the board will make a decision about signing off on the next phase of work with the engineering service agreement to get us through final engineering. So with that, what I'd like to do is turn it over to John and Dave to give just a short presentation on essentially kind of what we've done so far, what we've learned, where we are now, and then what's ahead of us for the work. So John, I'll turn it over to either one of you, and if you want to screen share, you should be able to. If you have trouble, let me know and I can help with that.
All right. Thanks, Charlie. And thank you to the town for inviting Hoyle Tanner to present some information on the planning for the town's wastewater system to serve both the village and the center. I'll keep it to some high-level broad brush aspects of the planning. Going back to July 2020, the town passed a bond vote to construct a town wastewater system, alternative 4A as it was called, and that was to include a grinder pump and low pressure force main collection system, followed by community septic tank treatment and conventional trench disposal to serve both the village and the center. There was an identified needed wastewater treatment capacity of 30,000 gallons per day for the village and 60,000 gallons per day for the center. And that is the 20-year design capacity that was identified. I'll just share my screen and share a few drawings that display that planned system. Charlie, could you enable screen sharing?
Yep. I'm going to make you the host.
Okay,
So you should be able to do that now. Just promise you give that function back at some point.
okay. Okay, this is a drawing of the
So I
village
think-
wastewater.
Just to be clear, we're not seeing it quite yet. So just, did screen share work?
Okay. Let me know when you see it.
Something's got.
There we go. It's coming up now.
So is it.
There we go.
Okay, and what I'm gonna do is I'm gonna dim the lights in the room just so folks can see this a little easier.
All right.
And board members are welcome to pivot or on the side of the table if you like. Okay, go ahead, John.
All right, this drawing depicts the village wastewater treatment facility. It is located on North Hill Road, which is this road here. It includes the large community septic tank in this location and 2 conventional trench disposal areas in this area here, as well as 2 conventional trench disposal areas in this area here on Black Falls Road. In the center, there were 2 wastewater treatment facilities planned, one on the south side of the Trout River. That was to include a large community septic tank in this location, and then the conventional trench disposal area in this location.
John, can I just pause you for 1 second? Could you just back up to the first slide, just to orient some folks in the room about what we're looking at? So this is Black Falls Road, the intersection with Black Falls and North Hill. So as we're coming up here, this would be essentially Jesse's Meadow on the side here. This is coming up, and this is where Jesse has been constructing the sugar house. So just to be clear, that there's no purchase and sale agreement for these properties in hand or even drafted yet. Jesse's aware that we're interested in the property for this purpose, but there's nothing under contract at this point. So just to be clear there. And then on the next one, John, if you want to just to orient folks. So again, the work to date has been looking at this area for the disposal system. This is what we're calling the clap lot. So this is the Benosh farm here. This is the access road that goes up the hill. And this is currently in corn, the meadow above the town. Just to orient folks about where you're looking, just so you know what you're looking at. Thanks, John.
Okay, thanks for that clarification. And so, again, with the center south site, there was a large community septic tank planned for this location and the conventional leach field disposal area planned for this location. On the north side of the river, the Center North wastewater treatment facility included a community septic tank located on this portion of the cemetery lot. This is the existing town of Montgomery cemetery. And then the conventional leach field area was over on this meadow here.
And just to be clear, John, these are just preliminary maps that were put together based on remote work, looking at things. This is not by any means something that's being moved forward with at this point. Just to be clear in the room that we're not looking at something that is being necessarily proposed to move forward with. These are basically alternatives that were looked at based on remote work and then investigated as to soil qualities, landowner, landowners' interest in sale, those kinds of things, right?
Yes.
Yeah.
And so with these preliminary engineering plans, we then did hydrogeological investigations of the disposal sites. And as we were beginning the hydrogeological investigation effort, we discovered that Purrier, the owner of this property here, was no longer interested in the project. And at that same time, we became aware of another property to the north of the Trout River on Route 242, a property owned by Walter Knight, who had expressed an interest in the project. And so when Purrier declined interest as the Center North wastewater treatment facility site and Walter Knight expressed interest, the Route 242 site became the Center North site. And so hydrogeological investigations were performed in 2021 to estimate the site disposal capacity. And the results of those efforts indicated that the Village North Black Falls Road site had limited disposal capacity. The Village South North Hill Road site had good disposal capacity. The Center North Route 242 site has somewhat limited capacity, and the Center South plat lot has good disposal capacity. And so, based on that new information, it was determined that the alternative 4A wastewater project, as it was defined prior to the bond vote and as approved by the bond vote, was not technically feasible due to the hydrogeologic limitations of two of the four sites that were investigated. And so, based on the results of the hydrogeological investigations, during the spring of 2022, we developed what we're calling Project Alternative 5, which was developed to include additional wastewater treatment to allow a higher treated wastewater effluent loading rate on a smaller site footprint and provide a technically feasible project on the sites that were identified as being good sites for disposal capacity. And so Alternative 5 includes one septic tank effluent pump tank located on each property in the service area, small diameter effluent force main to convey the primary treated septic tank effluent to the wastewater treatment facility. And the wastewater treatment facility includes a textile media filter to provide secondary plus level of treatment and drip dispersal of the treated wastewater filtrate into the soil. Each of the wastewater treatment facilities would also require a small 16-foot by 24-foot operations building about the size of a traditional sugar house. And I have a few drawings to clarify some of this infrastructure. This is a cut sheet of a typical 1,500-gallon step tank that would serve a typical family home. It's approximately 10 foot by 6 foot in footprint size and includes a septic tank effluent pump to pump the primary treated effluent. A step system includes a step tank and small diameter force main to convey the effluent to the wastewater treatment facility. Wastewater would flow by gravity, as it typically does from a home or business, through a gravity building sewer pipe into the septic tank. Solids settle out, grease and scum float to the surface and is captured in the tank, and the primary treated effluent is pumped into a small diameter force main. This line here is about a 1 1/4 inch diameter, high density polyethylene pipe buried 6 feet deep. And that effluent joins with a common main that includes treated effluent that is pumped by other users in the service area, and all of the effluent is pumped to the wastewater treatment facility. This is a layout of the proposed village wastewater treatment facility. It includes a 0.85 acre wastewater treatment facility located in this red box here. The treatment area is in this rectangle here, and then the drip dispersal area is up on this meadow here on a 1.78 acre area within this red shape. This is the red shaped fenced area, and then 2 drip dispersal zones, each being 72 feet by 144 feet in size. The central wastewater treatment facility is located up this 3,300 foot long farm road on the clap lot up in this area, and the central wastewater treatment facility layout includes this 3.78 acre fenced area, 2 drip dispersal zones in these 2 purple rectangles here, and here, each being 310 feet by 72 feet in size, and the center wastewater treatment facility area, which requires an area of 120 feet by 60 feet. And so these were the plans that were developed and submitted along with a report, preliminary engineering report supplement number 3, which was submitted in June to the town and to the agencies. That was followed by initial landowner discussions, and it was discovered that the owner of the clap lot, this lot here, is no longer interested in the project. Is not interested in selling the land for the project. And so Will Tanner reviewed available soils information and identified another site with good published soil information, and that is town of Montgomery Cemetery property right along Route 18. And this is the existing burial area of the cemetery. It is flanked by an area to the north that's currently used as a meadow, and an area to the south that's currently used as a meadow. The center wastewater treatment facility requires a minimum of 44,444 square feet, and this area here is 45,000 square feet, and this is 54,000 square feet. And so if one of these two sites is determined to have as good as or better hydrogeological conditions, then one of these two sites would be of satisfactory size to serve as the drip dispersal area. And so this is an alternate concept site to the clap lot, which the owner is not interested in selling the land. And so this is an area that is proposed for further advancement. In addition to the drip dispersal area, a new wastewater treatment facility area would be needed. This is a 60-foot by 120-foot area on a relatively flat ground, excuse me. And this is one potential site for the wastewater treatment facility area. There are other sites that are owned by the town in this general vicinity that could also be explored during final engineering design. And so published soil information indicates that Montgomery Center Cemetery site has good soils, and that is an area that we suggest be advanced in final engineering. I'd like to clarify what the aesthetics of such a drip dispersal and wastewater treatment facility area might be. This is an example of a similar textile media filter wastewater treatment facility located on Prince Edward Island in Canada. The treatment infrastructure essentially consists of a number of buried tanks. That's these green lidded tanks here. They are essentially at grade with the lawn, and the area is left as a mowed lawn. That's what it generally appears to look like.
That would be at the wastewater plant site, not at the disposal site.
That's correct. The center of wastewater treatment facility infrastructure tanks would be slightly larger, but there would be fewer than are shown in this picture here. The drip dispersal area, this is a photo of a treated wastewater drip dispersal soil-based disposal system during construction. It includes the drip tubing, and this photo was taken at a time during the testing of the drip dispersal system, and you can see the wet spots, and that is where the treated wastewater effluent or filtrate is being discharged into the soil through these precise emitters that emit 0.6 gallons per minute each emitter. And after construction is complete, this is a photo of a treated wastewater drip dispersal area. After the construction is complete, the lawn is established. This is for a residential application, and this is for a condominium community. It's basically a lawn area. Let's see.
And that's what would be at the cemetery site if it were chosen.
Yes. So
And if the hydrogeological work supports it.
that's correct. And so this aesthetic here would be, let's see, would be very similar to what is there now. It's basically a meadow. And then this other picture is what would be in this area here. And so that covers where we've been in the last 2 years, how the project has changed in definition since the original bond vote. Next I'd like to take a pause and ask her if there are any questions. I could hold questions till the very end, or I could continue on to discuss the engineering services agreement.
So John, I think it'd be great to pause now just for a few questions on some of the design features that have changed. One thing just to kind of clarify is initially we had talked about, actually, do you have more slides to share, or is this the end of the slide deck?
That is, I do have the sugar, or the operations building would have a similar appearance to a sugar house. It would be a similar size and shape. It wouldn't need all of the specifics related to a sugar house, but as far as the size and shape, it would be something similar to a 16 by 24 sugar house.
Okay, great.
And
It's located next to the
yeah.
tank.
And that would be located down lower, that would be the control building next to the treatment area, so that kind of at-grade green mat looking thing would be next to that small building in that place.
Yes.
Or, and as John said, conversely, the town does own land below associated with the rec center, so the location of that building potentially could be, relocated to the best situated site. Doesn't necessarily have to go in that one location that we're looking at. So John, if the slide deck is good, why don't we stop screen sharing, and that way we can have speakers up on the screen, and if you want, Charlie, could you just flip Suzanne, just flip the light switch back on? So John, one question for you, or clarification, is initially we had talked about each property having a grinder pump, and so there'd be a grinder pump which would basically take the waste, chew it up, and spit it down a pipe. In looking at the capacity we have and getting the sites to be suited for the capacity that they would allow, that's when we pivoted to the step tank system. And so,
That's right.
so under that system, each property would have a step tank, or potentially we're going to investigate whether some properties could potentially share a step tank. But each property would have a tank instead of a pump. The tank would have the tank would have a pump in it that would function similar to what the grinder pump was doing. But we're not looking at each property having an individual grinder pump anymore, right?
That's correct.
Okay. And then the tanks themselves would act similar to what a septic system, a conventional system does, except that the leach field function would be this wastewater collection system.
Yes.
Right? Okay. And
Each individual homeowner would no longer have a leach field. The effluent would be pumped to the town system.
yeah, okay. I just wanted to make sure that make sure that change was clear from the initial presentation of the system design. So Are there other questions just around the system, before we go to the next steps, questions around the system itself?
Yeah.
Kip Potter, couple of questions on those homeowner tanks. The first one is that can existing septic system tanks be modified for this use, or will new tanks have to be installed?
That's a good question, and it's something that we would like to investigate during final engineering. At this point, in the planning, this was considered a desktop effort, and we don't know the condition of existing septic tanks, but it's a reasonable thing to consider that many septic tanks, especially ones that may have been constructed recently, if they're precast, may be of a suitable size, shape, and condition that could continue to be used in service. And that's something that we have included in our scope of work for the final engineering work. Is reuse, consideration of reuse of existing tankage.
Thanks, John. And would the installation or upgrade of these tanks be included under the town's funding that they've received for
Yes.
Okay.
Under the funding program, one of the funding program requirements is that any project materials or infrastructure must be owned by the funding recipient. And so the town will end up owning, operating, maintaining, pumping out these septic tanks and all of the piping.
Thank you.
Great. Let's go to Mark in the room with a question.
So my understanding is it's gonna be 1.25 inch pipe coming off those tanks. What's the size of the main line?
It will range from 2-inch to 4-inch.
Wow. I operated the wastewater system in Richford for a few years, and I mean, I understand you got settling tanks and all that stuff, but it just doesn't seem like that's big enough to pump what we need to pump, but I guess, you know.
Do you know how big the pipes were in Richmond?
Well, pipes in Richford are
6 inch.
6 to 8 inch, and
Yeah.
I used to see some of the stuff coming in. You know.
Yeah.
Yeah,
But that was, this has settling tanks, so a lot of that stuff is settling out. So what's the estimate of how often we're gonna have to pump out the tanks at the houses?
well, the septic tanks have been sized larger than typical. And the reason for that is to extend the interval between pump outs. I believe the pump out interval that we've planned for is 5 to 10 years. So a typical homeowner septic tank would be 1,000 gallons, and this plan proposes a 1,500 gallon septic tank, and that allows for additional solid storage and scum and grease storage, but it also allows for the settled solids to decompose in the tank, and that reduces the amount of haulings of volume and mass that needs to happen on a periodic basis. And so the septic tank sizing is sized a little larger than typical to improve treatment. There's less solids carryover into the downstream treatment infrastructure, but then it also prolongs the pump out interval and reduces the overall operation and maintenance costs for the system.
So the town will be responsible for pumping these tanks out, not the home?
That's correct.
Okay.
And that's baked into the operation and maintenance budget in the budget stack. So
That's correct.
those costs are factored into the annual O&M costs, which factor into the annual total system costs, which we then derive the user fees from, plus the town's portion through the local option tax to basically cover the debt service on it.
Oh, okay.
Yeah.
I mean, you wouldn't have the grinder pumps to maintain.
Yeah, wouldn't have the grinder pumps to maintain, which is potentially a bonus there.
Yeah, because those can be,
Yeah.
yeah,
I hate to maintain those.
Yeah.
yeah.
Yeah, I see Larry with a question on Zoom. Go ahead, Larry.
These drip dispersal systems, you showed photos from obviously out of the area. Are there some available here in Vermont to see?
I have
Are
two
there
installed
others
on my
in
property.
There are some in Vermont.
Yep.
It is a relatively new technology in Vermont, but it has a pretty good track record throughout New England and throughout the country.
But they've never installed. So where would these be?
So Walt actually just said that he's got 2 of them installed on his properties up at Alpine Haven.
Yeah, it's Drip Bright name brand, but it's the same technology.
So we've got a couple
That's who we're working with.
same.
Right.
If there was a massive amount of curiosity at a scheduled time, I can show someone what mine looks like. It's gonna look very similar to a field. Mine required an addition of a couple feet of sand because I don't have the correct soil quality. So we raised it anywhere from a foot to 2 feet to 2.5 feet, depending on the undulation of the area. But to give you an idea of the size I had put in, I had one of my properties re-engineered for 7 bedrooms and a 50-person event running at the same time. So I'm 12 by 65 or something like that. So yeah, if someone really wants to know through the select board, I can make it available to show them what it looks like.
Great, thanks, Walt.
John, are there other sites other than Mr. Knight's available to look at nearby?
I can get a list of other sites and provide that for you.
Thank you.
Thanks, Larry.
John, have you ever put one of these systems in?
A drip dispersal system?
Yes.
No, I haven't.
Thank you. Thank you all.
Thanks, Larry.
Thank you, Larry.
Yes, Rita, I see you have a question.
Hi, you mentioned, John, about a 1,500-gallon tank for property, but are there different sizes of tanks if you've got a commercial place? Like I have a 6 apartment unit building on Main Street. Clearly, that.
Yes. The tank size would be based on the unit, the design flow for the sewer user.
Okay.
So businesses would typically be larger than
Okay, thank you.
a typical family home.
Thanks, Rita. Other questions? I had to laugh. The pipe diameter thing brought back memories of how they deal with this in parts of Europe. We'll just have trash cans next to every toilet.
Exactly.
If you know what I mean.
Solid waste. Oh, yeah, I know exactly.
It's a surprise for anybody traveling over there. Great. So if there's no other questions in the room or on Zoom, we can move into kind of the what's next, what goes into the final engineering. And again, this is the engineering service agreement that is on the table essentially for the board to consider.
Yeah, so the next step is the review and approval of the engineering services agreement. This is referred to as step 2 in the CWSRF funding program parlance. Step 1 is planning or preliminary engineering. And so the step 2 final engineering agreement was prepared and submitted recently, and that work will include all of the necessary field surveys to perform the final engineering design. We will develop final design drawings and construction contracts for bidding of contract 1, which is proposed to include construction of both the village and the center wastewater treatment facilities, including drip dispersal zones. And then it will also include development of final design drawings and construction contracts for bidding of contract number 2, which is the on-lot septic tank effluent pump tanks, as well as the off-lot collection and conveyance force main work. And the step 2 final engineering agreement amendment amount is $1,421,274. And we have included in the agreement The indications for the high priority tasks that needed to be completed before this coming winter in order to keep the project on schedule. And the value of those high priority tasks is $603,630. We've also included a term that Will Tanner will not work past the high priority tasks without town go-ahead approval. And so that's a summary of the engineering services agreement work. Are there any questions?
John, it might be worthwhile just to mention that the contract includes a considerable amount of work by subcontractors and subconsultants. You might give some examples, the hydrogeology firm.
Yes, our field surveys include a professional land surveyor doing topographic and utility survey. The funding agency and funding terms require that an archaeological resource assessment be completed over the entire project area. We have a subconsultant to do that work. We have a geotechnical engineering consulting firm that is plans for completing soil boring work to collect soil information that will be needed by the general construction contractor to prepare his bid pricing for the force main work. We also have wetland scientists to complete wetland delineation. We have an electrical engineer to complete the electrical engineering aspects of the project. Let's see, we have
Stone.
and we have Stone Environmental, who is our hydrogeological consultant, and they have a significant scope of work related to the investigations for the cemetery site and for the significant effort of permitting with the state of Vermont's indirect discharge program. We have an environmental laboratory on the team. We are going to collect soil samples in both the village and the center to analyze for environmental contamination, and that is an effort to reduce construction risk. A lot of these linear projects occasionally run into environmental contamination, and if the work is not clearly defined ahead of the project, there can be significant cost overruns. And so, as a risk reduction measure, we'll be taking soil samples and completing the laboratory analysis work to better define the construction risk and the construction work that is needed. Dave, did I leave any sub-consultants out?
Well, another aspect of it, I think, is you could call it value engineering aspect. One of the benefits of actually changing the center site to the cemetery site is a significant reduction in cost. The cemetery site is closer, right? Am I saying this right?
That's correct.
Closer to the source, and
The center south, the clap lot was approximately 3,300 feet up a farm road that would have required improvements to both the road and the old farm bridge that goes over the south branch of the Trout River. And so relocating that site closer to, the service area will reduce the construction costs associated with not having to construct or reconstruct that road, bridge, and not having to construct 3,300 feet of utility poles and electrical power wiring up that road. And so that is one of about a half dozen potential likely cost saving items that we've identified that we will investigate further once we get better topographic and utility information. It's something that we really need to do during final engineering to really determine whether some of these ideas are gonna really result in reduced costs. But Kip brought up the idea of reusing some of the existing septic tankage that is already in use if it's in good condition and of suitable size. We're going to investigate that as well to see if there can be project cost reductions.
Great, we have a question in the room from Mark.
I operate the water system, and the well, I don't know if you realize that the town well was at the recreational center, the old well. And that's being kept as an emergency backup for the system. So in the source protection plan, we still have the source protection area over there, which is 200 feet around the well. And then I just want to make sure you realize that area that's there. Yeah.
We are aware that there is a well there.
Okay.
And we, as part of our hydrogeological investigation work for that site, we would more clearly understand the potential influence of this system on that well.
Okay.
But whether there is an influence or whether there's not, we'll have a clearer picture once we move through the hydrogeological investigations for that site.
Okay. I just wanted to make sure you knew that.
Yeah, sure.
And John, just to clarify, so the ESA that we've got before us now, as well as every other thing that's come out of the project, everything that we're doing gets reviewed by our friends at DEC to look at basically, the efficacy of what you're proposing, the costs of what you're proposing. DEC basically acts as our agent in this process because none of us are wastewater engineers, and so they basically are the ones that look at it and say, okay, this makes sense, or this makes no sense whatsoever, these costs are inflated, all that kind of stuff. And just to clarify, DEC has looked at all of this through the process, and they've reviewed the ESA that we're looking at now, and they've signed off on it as being essentially good to go from their end, right?
That's correct.
Okay. Other questions for John or Dave? I do want to open it up just to general discussion in a minute, just to talk about different aspects of this with folks in the room. But any other engineering questions Dave and John can help with? Yeah.
I remember the grinder pumps that were originally proposed were fairly minimally invasive as far as installation and construction. So these new step tanks, are those gonna be a lot greater of a impact, at least during construction? As far as tearing up lawns and driveways and things like that?
That's a great question. Did you hear the question, John?
Was the question, is the construction of the step tanks more or less or equal to the grinder pump construction installation with regard to impact on homeowner lawn areas and that sort of thing? Is that the correct question?
Yeah. Basically, yeah.
I would say the step tanks, they're a little bit larger in footprint, and so it is going to be a little bit larger impact on each of the individual properties.
And that brings up an interesting point too that you and I have discussed, John, and that's that conceptually the infrastructure for the systems, it isn't going to run along Main Street. It's going to run behind Main Street, and so basically the infrastructure, the piping, the tanks, all of that's going to be essentially behind the houses. So it's not like the front yards along Main Street and Main Street proper are where that's going to be installed. Is that correct?
That's correct. In general, we've avoided Main Street because of the typically high costs associated with construction of utilities in a state roadway with existing utilities. In addition to the typically high costs, the Vermont AOT may not even allow it. And I was just reflecting on my answer. It's perhaps the first time I've really thought about the question of whether the installation of a grinder pump is more or less or equal to the impact of construction of a step tank. And as I think about it more, although the installation of the grinder pump is a smaller footprint, we're typically having to remove the existing septic tank and replace the grinder pump in the septic tank location. And so I'd like to just revise my answer and say it's kind of a wash. I think no matter what, during construction, things are gonna appear like we're under construction all over town.
Yeah.
Yes. Yep.
Yes, John, I assume you could get the same level of secondary treatment that you would be getting from the individual homeowner step tanks in a centralized facility. Did you look at that as an alternative at all, and what that would entail?
I'm not sure. Have we looked at what type of?
Well, right now you're getting additional treatment with the individual homeowners step tanks, right? You could also,
Grinder pump?
not a grinder pump, but you could also get that same level of treatment in some sort of centralized facility.
Now, you're talking about the existing septic tanks?
No,
Oh,
in a centralized facility that'd be associated with, the collection system, where the textile filters are going to be located as well.
We did look at a conventional wastewater treatment facility infrastructure early on,
Okay,
and basically removing the existing septic tanks and replacing it with gravity collection sewer to a central point, and then providing conventional wastewater treatment facility treatment. And those costs are very high. The cost of constructing conventional gravity sewer with 8-inch diameter pipe, large trenches, manholes every 400 feet. The gravity sewer has to be constructed on grade. It's typically constructed right down the roadway. And then in the village, for example, I think we had 3 or 4 different pump stations, which are high cost, and in the last decade, due to new requirements, are becoming even higher in cost. And so this system falls under a category of wastewater treatment that's referred to as decentralized wastewater treatment. The overall goal is to treat the waste and dispose of it as close to the source as feasible. And that this system falls within that category of treatment and is considered to be of the most economical for these small flows below 250,000 gallons per day. The decentralized approach tends to win over economically.
and I think for that reason, the town is able to benefit from a funding program aimed directly at this type of system, this indirect discharge type of system, and that funding program is not available in the same way for conventional wastewater treatment. And, the town is getting a very, very high percentage of this total system and in essence solving an issue, a wastewater issue, both in the village and the center, with very significant contribution from the state.
The state and the federal government, I think the grant percentage is nearly 90%
Yeah, it's like 90,
on the total project cost.
93, I think, last time we looked. Which is, I'm pretty sure, the highest grant percentage any community in Vermont's ever had on a project like this.
And, further, what I would say, just observing the progress of the project and so forth, is there's quite a bit of political and institutional momentum to this particular project. State and the federal government are very, very committed to this project.
Thank you.
Thanks, Kip. Other questions for Dave or John at this point, before we kind of just open it up for conversation? All right, if not, then we'll kind of pivot to just conversation about what we've heard. Dave, John, you guys are welcome to hang out and hang on, but also you're welcome to go get on with your evenings. I really appreciate you taking the time to sit down and chat with us tonight.
Yeah, well, I think we'll hang around for a little while, and Charlie, we're interested to hear what folks have to say, and who knows, another question could pop up.
Awesome. Well, thanks so much.
Thanks, Charlie. I just had one more comment, and that is, looking forward, we're targeting the construction for 2023 and 2024.
Yep. And so to that end, that's why one of the things John said was that, when we think about, this field season, this late summer, fall, and the work that we're looking at doing, if we don't get that work done this late summer, fall, it pushes us to next year and pushes things back to a point where the issue is a lot of the money in the funding stack that we've got has to be expended by a certain point, I think the beginning of 2026. And so 2026 seems like a long way away, but given the timeline we're on, we want to make sure that things are moving if we go forward with it, so that we don't end up in a position where a good percentage of that funding stack disappears because we haven't used it in time. And that's primarily the ARPA funds that the state is putting towards the project, which right now I want to say are upwards of $4 million when you combine all of the different facets of it. So it's quite a bit of money. Yeah, Kip, go ahead.
One more question. So based on that schedule, do you think that homeowner hookups would actually occur sometime in 2024?
Yes, we're targeting to complete construction of the wastewater treatment facility and drip dispersal areas first, because we can't disable an existing septic tank until it has a place to go. And so we're planning to do the wastewater treatment facility and drip dispersal areas construction in 2023, and then, as you mentioned, Kip, the on-lot work would be 2024.
Okay.
Thanks, Kip. So I want to open it up just to kind of reflections on what we just heard and thoughts about what we're going to do here. I do want to talk a little bit about just the proposed disposal field for the center that is now on the table, given everything else happening, which is the meadow, one of the meadows up by the cemetery. So I'm glad Charlie was able to come tonight. And I've talked to Charlie about this a little bit before, but that's a consideration. Just, the town does own the property, so there are some potential cost savings there with land purchases. The location of it potentially has some cost savings, but it would be a decision by the select board as to future use of that area. So Charlie, I just want to give you a chance to kind of reflect on that. I know that you guys have talked about plans for expansion, but I want to just give you a chance to talk about that.
Would it be both sides or just one side?
So under this proposal, what they would do is they would do test pits on both sides to figure out which one has the best capacity, and then only one side would be used. So under this scenario, one side would end up getting used for the drip dispersal, the other side would still be open to cemetery expansion.
Because we were definitely running out of space.
Yeah.
Within a few years, we're gonna need people just dying to get in there.
So it looks like from the maps that either one of those meadows would basically add maybe like 2/3 capacity to the cemetery up there. Is that kind of a?
Yeah, it wouldn't look nice and orderly because neither of those go the whole distance that the cemetery is in length.
They're not square.
No,
They're more like triangles.
Partial of the length, and one is more to the front and the other is more to the back.
Mm-hmm.
Oh, yeah.
But, yeah, my other question was just, putting that much water in the ground, hopefully that's not gonna create issues, you know, in the cemetery as far as when you dig a hole.
Yeah. So I don't know, John or Dave, if you heard the question, but the question was if we had the drip dispersal field adjacent to the cemetery, would that affect the soil hydrology in the cemetery to a degree where it would essentially impact the use there? The question was about digging a hole in the cemetery and having water be in it. But I think more generally, like, are there any hydrologic impacts to the cemetery that this could create?
Well, we wouldn't really know for certain until after, or know better until after the hydrogeological investigations are completed. However, I wouldn't, just from the available information that we do have, those two areas of interest that we have are down gradient of the existing burial area. And if those soils are, as we anticipate and hope they are, similar to the center-south, the clap-lot soils, those soils were very well drained. I believe we had estimated well more than 40 feet of unsaturated soil before hitting the water table. And so if those two areas adjacent to the existing burial area are similar or better than the clap lot, it would be very difficult to say that the proposed drip dispersal area would have any impact on anything. If it's as good as the clap lot. I would not anticipate there being water in the hole. If it's as good as the clap lot.
I would agree with that. Right now, the current burial area does not appear to be in the flow path of groundwater flow, if you will, on either side, either of those meadows. But that would be confirmed during the hydrogeological investigation.
The other issue could potentially be erosion, because that is high and it drops off sharply on both sides.
So erosion you mean erosion off the banks
Right.
associated with, yeah, so the question.
Or undermining, you see that a lot from that area.
Yeah, so the other follow-up from Charlie was just around erosion and the undermining of soils, because as you can see on the maps, those areas drop off very steeply. And there have been issues in that kind of contour around the center of slope movement, and so if you just want to speak to how that would be addressed.
The loading rates that are proposed are not anticipated to have a destabilizing effect on those steep slopes. We would be locating the drip dispersal areas a certain distance away from the top of the slope, and the treated filtrate flows downward in the soil to rejoin the water table, and the hydrogeological investigations evaluate that matter.
Has there been any soil instability examples or concerns?
I don't know, at that site or
Well, not right at
Yeah.
the site, but in that
Elementary
larger,
school.
in that area there have been.
and also at
All right,
school.
but
Yeah.
you know, that will have to be taken into account during the preliminary design phase.
Okay,
If there has been any issue with soil slope instability, for sure, that would have to be taken into account.
great. Other questions or just reflections, people's thoughts based on what we've heard?
So, we say yes to this, and then they do all their testing,
Yep.
and it still comes out the site isn't feasible, then it's done? I mean, if there's no other site?
Yeah, I mean, essentially, if we go forward with this, they do the test there and the sites are determined to not be feasible, not work, then if there's no other alternative sites, which it's looking like there are not, then it would be a case of we don't move forward, or I imagine there's a mechanism there whereby there could be a full-scale redesign of what we're doing, you know, like the treatment would be much, much different, but that would be a very different kind of picture. But John or Dave, I mean, can you speak to that just around, I don't know if you heard the question.
Yeah, we did.
Dave, okay. So, if the cemetery site were determined to be inadequate or inadequate to cover all of the center wastewater treatment facility needs, the Route 242 site did have some identified capacity. It wasn't as high as the center south site, and so that is why we focused on the center south site. Because we were focusing on the center south site, we put the completion of the Route 242 site hydrogeological investigations on lower down on the priority list. But where we left it was that there appeared to be nearly 30,000 gallons per day of capacity at that site. But that had not been definitively determined. That was an estimate, and Stone will be completing that work shortly.
But there is,
It is a very limited site area of 0.5 acres, and it is also quite a ways outside of the service area.
but there is good reason to be optimistic about the cemetery site because of the way where it is, you know, elevation-wise. And John, what did Amy at Stone Associates say that they hit the jackpot with the glacier or something along those lines? So you've got
The town of
significant.
Montgomery won the geologic lottery in these sand deposits that are surrounding the center and you know, to a certain extent in the village as well. Unfortunately, it's not in the center, it's up and away, but there is a tremendous amount of these sand deposits, at least compared to other Vermont communities.
Yeah, what we need is relatively permeable subsoils. We need some depth to groundwater. And the other factor that gets looked into here is that we need enough natural treatment to occur before the groundwater ultimately flows to the surface water body, which we are required to be sampling for water quality to ensure that whatever gets built and puts into service doesn't degrade the quality of the stream,
Or the Trout River,
trout river.
or receiving water body.
So, so that, you know, there is a risk here. That, as John said, that there's work, the higher priority work, that if it doesn't get done by winter, sets the whole project back and puts some of the funding at risk. But part of that high priority work is the hydrogeological work. And, you know, if for some reason these sites don't work out, or the cemetery meadows don't work out, then either we'll start looking for an alternative, a plan B. But most of the contract that we're discussing tonight doesn't get spent by that point. But you know, a fair amount of money does.
Yeah, Walt, did you have a?
I'm just gonna comment on something I guess I haven't bothered saying before, but for those of you that are paying attention to this meeting and before, you'll see that I'm the owner of the 242 lot that's been referenced. I have never once said, I want to have the septic on that, or the treatment on that land. What I've said is, I I will allow it to happen and we'll come to an agreement if it's deemed necessary. I would much rather build something beautiful on top of that meadow. So I don't know if it's ever been expressed, but Charlie can tell you, I've never pulled or desired or gone after trying to get a piece of the pie and have this built on my land. I was approached, it was made available, and I'm agreeable to it if it becomes necessary. I just want that said, that it's not something I've pursued.
Yeah. And I'll mention too,
I
Walt
just
was,
thought your lot was a little bigger than 25, that area.
yeah. And I'll just point out too that Walt was initially part of the committee working on this when it started up, and the moment that that site was identified as a potential site to be looked at, Walt gave me a letter resigning from the committee and that work, and has basically stayed at arm's length since then, so, just to be clear about
Yep.
firewalls and things. So, other thoughts? I do know, so Emily and I did go up to the meadow last week after our other meeting, just because I don't think she'd seen it or that way before, just to look at it. And did you have any reflections on kind of what you thought going in and what you thought coming out based on what we were looking at?
Coming out, I felt much better after looking at it. It seems when you go up there that they are definitively different lots.
Right.
The tree lines that are there break up that property, and so it didn't feel as invasive to me as I'd originally thought that it might, to think about a disposal site being up there. So that was sort of my takeaway. But I think that there's still a fair amount of investigation, obviously, that has to happen in order to ensure the integrity of what's already there. There are there's a nice tree line on either side of the existing cemetery, and I do think that it's really important that we honor the cemetery, and so moving forward, one of those areas seems really reasonable, in my opinion, I guess, to move forward, but not both, because what Charlie's saying is that there needs to be expansion up there as well, and so I think that, if we were to find that one of those meadows will not be the capacity that we need, then we need to look toward, 242 to be the other. So I in no way, shape, or form would support taking both of those spaces for this project.
Yeah.
That was my takeaway from being up there and looking at it.
Yep.
Ultimately it seemed to me like if you went up there and you were looking at it, that the left-hand side, which is that the north side?
That would be the northwest side is the left one, yeah.
Yeah, so the northwest side, it seemed like that's sort of tucked away, and maybe the expansion to that right-hand side, but obviously, you're far, far more familiar up there than my visit, so I don't know what the cemetery commission is envisioning, if they had, is there a preference?
I don't know that we discussed that, we've discussed one side or the other, but I think the right side would probably blend with the cemetery better, the south side.
South side, yeah.
It's more closer to the same length,
Yeah.
and like you say, the north side is more tucked away, and we could almost hide it better over there.
Yeah.
The other aesthetic thought I had would be nice to not have that building near there. Just because when you go up there, it's kind of quiet and nice, and there's no buildings there.
Yeah.
If it would be possible to put that down lower somewhere, maybe.
Well, and there's no noise up there either,
Right.
so
Yes.
that would be nice to maintain that.
Yeah, so if there's the ability to center that building, again, there's options we can look at with how the town owns the land in there, whether it's lower, out behind where that pump track is. but yeah, I agree, having that facility there could be, problematic.
The other issue up there is it's flat on top, but boy, it's steep all the way around.
Yeah,
So it makes it difficult to place anything near there.
yeah.
I would just remind everyone, I mean, I don't have too many people online, it looks like, but it was fun that you chose a sugar shack as the idea of what the size is. I'd remind everyone that aesthetics can be determined by the town. If you want it to look like a sugar shack, it can look like a sugar shack. I mean, you can make it look like whatever you want. It might cost an extra $20,000 in prettying it up, but I mean, if it goes in a spot, I agree, maybe a little further away would be nice, a little quieter. But if it's gonna be visible, you can choose what you want it to look like.
Okay. Other thoughts, Mark? Yeah.
Charlie, have you talked to the rest of the cemetery commissioners?
No.
Oh, you haven't?
No, but it's not, I mean, we only control the actual cemetery, that's town land.
Yeah.
Size.
Oh, okay, yeah.
You know. I haven't talked.
Try to work together though.
Well,
Yeah, yeah, I mean, that's what I
talked to them
mean.
about this, I mean, we talked about expanding.
Yeah,
But not about
oh, okay, yeah,
the septic system being there.
yeah.
Well, one of the hopes, or one of the reasons why we're recording this in two different ways tonight is so that folks who aren't here tonight can catch up on it and be able to see and hear what we're hearing and looking at, so that folks who haven't been involved can get caught up on what we're talking about.
Yeah.
I do think it's advantageous, the idea of putting it on land that we already own. I mean, as one, just, if it can be respectfully done next to the cemetery and that's like visually, subtle, I mean, it's just like, it's gonna essentially be a big lawn. The fact that we already own the land is kind of a
It's a
big
big plus.
plus.
And
Yeah.
It'd be a cost-
proximity to power
Yeah,
and everything else, you
yeah,
know,
all
I
the
mean,
factors.
it's so much
Existing
better.
road there, infrastructure's nearby, like,
One way to get a good road to the cemetery.
Wow, it's questionable
Yeah.
winter time.
Yeah.
Yeah.
Is the drip dispersal system new technology, or is it just new technology to Vermont, this area?
Just John, you don't give John a chance. John or Dave, did you hear the question?
Yeah, it's recent technology. John's mentioned, we have a whole list of installations in New England, including in Vermont. We just don't have it in front of us at the moment. A lot of people are starting to use it. I know our competitors, other engineering firms, are designing around it and specifying it because it is an improvement on conventional trenches, leach field type trenches. It operates under pressure, or light pressure, so the distribution of the liquid is more uniform. And John helped me here. We get it can actually be smaller, right? The area is actually smaller than a conventional leach field.
That's one of the number of significant benefits of the drip dispersal system compared to conventional leach field, is that you can get about twice as much loading rate into the soil, and so that's how we wouldn't even be talking about a project unless it was drip, because we lost half of the land that we needed when with the center north meadow no longer being on the table, and then the clap lot, or the village north meadow going off the table. As Dave indicated, that when this system operates under pressure, it delivers a very precise amount of treated effluent to the soil, which is different than a conventional trench system. And it's dosed in such a way that it provides a drying of the soils. It's a includes a rather effective filtration, and it filters down to roughly 1/1000th of an inch. So particles down to 1/1000th of an inch in size get filtered out and recycled. And so the quality of the water or the filtrate that's being applied to the soil is far cleaner than a conventional system. And that results in a much longer service life. The soils don't become plugged as conventional systems do. As Dave mentioned, it's a newer technology to Vermont. It's been widely used throughout the country for at least a couple of decades in wastewater service such as this. But the technology was originally developed in arid climates. I believe it was originally developed in Israel for agricultural purposes, where they needed to deliver precise amounts of water to agricultural crops in a place where they didn't have a lot of water. And so the technology of this drip technology, the broad drip technology, is really many decades old. It's come to this decentralized wastewater application within the last couple of decades, and it's become very much more used in New England in about the last decade or so.
I have a question.
Yeah, Brent, go ahead.
In regards to, not that we lose our power very often up here, but how long would the system operate without power? 3 days, 4 days?
Well,
Is there a backup power source needed for the system to operate, or?
Yeah, each of the wastewater treatment facility locations would have a diesel backup generator.
Okay.
That would be automatically that would be designed and constructed to automatically turn on a loss of power signal.
Right.
And then to the rest of the system, the step tanks will have pumps that will rely on grid power. And so if there is a power outage, then the step pumps will not operate until the grid power is restored. And we estimated that the step tank volume is suitable for about 3 days of what we called power outage water consumption. And so with a power outage, you're not using the dishwasher, you're not using the laundry washing machine. The town, both the village and the center, do have a town-owned potable water system, and so water is available for showers and for washing, but is typically at a reduced rate during a power outage. And so we made some what we think were reasonable and conservative assumptions that during a power outage, this system would provide basically storage in the septic tank for about 3 days of reduced usage, and then the grid power is going to need to come back on, or people would have to really curtail water consumption.
Okay, thank you.
And to that point, and perhaps to a value engineering discussion that we were having earlier, another area of value engineering that we will be considering is perhaps I won't get into that. There's another value engineering related topic to that matter, but we could go into that at another time, I think.
And those will be determined through the final work of the ESA, so.
Yes.
So, John, I have one follow-up question with regard to, say, a long power outage. If the power were out for 3 days and all of these systems are sort of these step tanks are at max capacity, after 3 days, is our the power kicks back on, is our system then inundated, or does it manage pretty well?
It would manage pretty well. The pumps are high head pumps, and they would turn on and pump the flow to the wastewater treatment facility. The wastewater treatment facility does have significant equalization at the facility, and so I don't anticipate that there would be a problem. The treatment facility is designed to handle it.
Thank you.
Any other questions or thoughts, feelings, emotions related to this?
Well put.
So I'm assuming that these systems have been in use in New England, so freezing is not a problem.
Do you hear the question? It was related to freezing and whether freezing would be a problem given the climate here, depth of frost.
That's a very good question, and it's a question that we really had at the front of our minds when we went into this, because we know Montgomery is not just a cold climate area, but a very cold climate area. And we have taken measures within the preliminary engineering design of the system to ensure that the system will operate without freezing problems. The drip dispersal system is designed to drain after every dosing cycle, and so the drip dispersal tubing would be designed to be installed at a very flat to sloping back towards the treatment area, so that when the dosing cycle ends, all of the filtrate that is still in the tubing but not yet flowing into the soil, it will get sucked back into the drip dispersal feed well. And the septic tanks themselves, we've designed in a preliminary sense. The preliminary design is calling for insulation around the tankage to prevent freezing. Realizing that some of these properties are seasonal use and may not have regular flow to them. And so the preliminary plan has taken the very cold climate of the village and the center into consideration, and we've included methods to retain heat within the system so that there won't be freezing problems.
Good, thanks, John.
So the drip area, there's no surface water, that water's all below the ground, right?
Yeah, the drip dispersal area is subsurface. It's all, yeah.
Yes, the drip tubing is either plowed into the soil or placed on the soil with about a foot of soil cover between the top of the tubing and the ground surface.
So there's no odor either.
There's no odor.
Only after
And
Mexico.
all of the wastewater treatment facility tankage is closed. It's not exposed to the surface or to the ambient air.
Any other questions or? Yeah, well,
Just reiterate, if, like Charlie's question is good, I would tell you, again, I was serious. If someone wants to contact the select board and would like to see one of these sites in operation, you won't see much, but you'll see what, I have 2 of them. So just through the select board and we'll make an appointment and it's no problem.
thanks, Walt. So the question before the board tonight is to whether or not to move forward with this ESA agreement to do the work we've discussed. That's the decision point that we're at now, that we gotta make to either pause it and do something different or move forward with what's being proposed. So I don't want to curtail conversation or more questions if we've got them. That would be the question tonight for the board.
So we decided to move forward,
Yep.
and then everything will come back to us like where the site's gonna be and where the building's gonna be and all that, so we have a decision if
Yeah,
that's
so
all
it's-
right with us.
As John said, the ESA is broken up, and as, if you read it, you'll see it's broken up into different phases. And so the first phase of that
Could be
must
testing.
do testing work, the test pits, the site inspections, all that's gonna happen up front.
Yeah,
And then there's a hold point in there, and that gets through about 600,000, I think, of the ESA amount. That'd be the hold point where they come back to us and say, okay, here's what we found, here's what we're gonna, and what that tells us going forward.
and then that would, we making a decision to move forward from
And
there.
then we'd sign off on continuing with the rest of it, which would be the second part of that, the scope of work in there.
When would
Yeah.
that decision be made?
John, do you have an idea of when you'd come back with the completion of the first phase of the ESA? I mean, when that information would be available for the board?
Well, there's a number of different aspects or tasks within that that first high priority task list. But I would say by the end of this year, we would probably be coming back to the board.
Yeah, because there's a field work component and then like a desktop component processing it all, so end of year,
Okay.
okay. So, to move it along, I would move that the board, sign off on the, we got the right name for it. I would move that the board sign off on the owner-engineer agreement amendment number 6, to progress the scope of work that's been discussed tonight.
I'll second that.
Thanks, Leanne. Is there any other discussion? Not hearing any other discussion, we'll vote. All those in favor, please signify by saying aye or raising your hand. Aye.
Aye.
Any opposed? Any any abstentions? Great, the motion carries. So we'll get this paperwork to Hoyle Tanner to get the ball rolling on that, and we will continue to just get the information out as we get it. So if there's no other business to be conducted tonight, then a motion to adjourn would be in order.
Charlie, do you need a motion? We need to get the loan agreement.
Yeah, so as soon as that's together, then the board would sign off on the loan agreement, so I'll connect with Lynette on the timeline for that. But that would be a separate, because once that paperwork comes, then we do all that separately.
Okay.
Yeah,
I'll make a motion to adjourn the meeting.
great.
There you go.
Is there a second?
Awesome.
Great. If there's no discussion, all those in favor, please signify by saying aye.
Aye.
Any opposed? Any abstentions? Great, motion carries. Thanks, everybody. Thank you, everybody online. Thank you, Dave. Thank you, John, very much for your time this evening.
Thanks, everyone.
Thanks, guys.
Thank you.